In this lesson, we are going to introduce you to trigonometry. In grade 10, this will always involve a right-angled triangle. In trigonometry, people like to use Greek letters to show angles. Here we use the Greek letter theta. In any right-angled triangle, the side opposite the right angle is called the hypotenuse. Also note, this hypotenuse lies next to the angle theta. On the other side of theta is the side adjacent to theta. And the third side is the opposite side because it lies opposite theta. Let's recap. The hypotenuse always lies opposite the right angle. The adjacent side lies next to theta, and the opposite side lies opposite theta. This will always be true, no matter in what position the triangle lies. There are three important ratios in this triangle. The first is opposite over hypotenuse. Next is adjacent over hypotenuse. And the third is opposite over adjacent. These three ratios have special names. The first one is called sine of theta, or just sine theta. The next ratio is called cosine of theta, or just cos theta. And the third ratio is called tangent of theta, or just tan theta. This information is extremely important in trigonometry. Let's go on to see how to remember it. The order is always sine, cos, tan, or SCT. Then you need to remember, oh heck, another hour of algebra. And from now on, I will use the letters O, A, and H for opposite, adjacent, and hypotenuse. These are the first letters in oh heck, another hour of algebra. Please note, it does not matter how big or small the triangles are. If the angles are the same, the ratios will always have the same value. In other words, sine theta will have the same value in both triangles. Cos theta will have the same value, and so will tan theta. Let's go on to see how to use all of this information. Here is the first example. We are given a triangle and are asked to find sine theta, cos theta, and tan theta. Step 1 is to identify the sides of the triangle. The hypotenuse is easy, because it is the side that lies opposite the right angle. The side next to theta is the adjacent side, and the side opposite theta is the opposite side. Next, we need our three ratios. Remember the order is sine, cos, tan. And then, oh heck, another hour of algebra. The first ratio we are asked to find is sine theta, which is opposite over hypotenuse. From the triangle, we see that opposite is 6, and hypotenuse is 10. So the value of the ratio, sine theta, is 0,6. This completes part 1 of the question. In part 2, we are asked to find the ratio cos theta. First, we need to recall that cos is adjacent over hypotenuse. Using the triangle, we see that this is 8 over 10, or 0,8. This completes part 2 of the question. In part 3, we are asked to find the ratio tan theta. First, we need to recall that tan is opposite over adjacent. Using the information on the triangle, this is 6 over 8, which gives an answer of 0,75. This completes the question. Click pause if you need more time to check the working. Here is the next example. We are given another triangle and are asked to find the same three trig ratios. Again, we begin by identifying the sides. Hypotenuse lies opposite the right angle, adjacent lies next to theta, and opposite lies opposite theta. But we have a problem. Can you see what it is? The length of the opposite side has not been given. Now what? Because this is a right-angled triangle, we can use Pythagoras to find the length of O. We can write that O squared plus 15 squared equals 17 squared, which means that O is equal to the square root of 17 squared minus 15 squared. This gives an answer of 8, which we write in on the triangle. We are now ready to find the values of the three trig ratios. To help us remember them, we write down sine, cos, and tan. And then, oh heck, another hour of algebra. This reminds us that sine theta is the ratio opposite over hypotenuse, which in this case is 8 over 17. 8 divided by 17 is equal to 0,5, correct to one decimal place. This completes part 1 of the question. In part 2, we are asked to find the value of cos theta. First, we need to recall that cos is the ratio adjacent over hypotenuse, which in this case is 15 over 17. 15 divided by 17 is equal to 0,9, correct to one decimal place. This completes part 2 of the question. In part 3, we are asked to find the value of tan theta. First, we need to recall that tan is the ratio opposite over adjacent, which in this case is 8 over 15. 8 divided by 15 is equal to 0,5, correct to one decimal place. This completes the question. In grade 10, you will also be required to do trigonometry on the Cartesian plane. Here we are given point P, the point in the first quadrant. We can use this point to draw a right-angled triangle. To do this, we draw a line from P perpendicular to the x-axis. The length of the side on the x-axis is x, which we get from the x-coordinate of point P. And the length of the side parallel to the y-axis is y, which we get from the y-coordinate of point P. The side which joins the origin to P is always labelled R. The angle, which is always measured from the x-axis to R, is theta. R is the hypotenuse because it lies opposite the right angle. X is the side adjacent to theta, and y is the side opposite theta. The three trig ratios are sine, cos, and tan, together with, oh heck, another hour of algebra. This means that sine theta is the ratio y over r, which is the ratio opposite over hypotenuse. And cos theta is x over r, which is the ratio adjacent over hypotenuse. And tan theta is y over x, which is the ratio opposite over adjacent. These are the ratios you need to use when doing trigonometry on the Cartesian plane. Let's see how to use these ratios if they give us the point 3, 4. First, we complete a right-angled triangle by drawing the following line perpendicular to the x-axis. The x-coordinate of P is the length of the side on the x-axis. The y-coordinate of P gives the length of the side parallel to the y-axis. To find the length of R, the hypotenuse, we again need to use Pythagoras. The length of R is therefore 5. We are now ready to find the three trig ratios. Sine theta equals 4 over 5, or 0,8. Cos theta equals 3 over 5, or 0,6. And tan theta equals 4 over 3, or 1,3, correct to one decimal place. It is now time to test yourself. Good luck.